All right, let's work on this problem. We want to give a 5-number summary and we want to work on some percentiles. So I have a data set here that contains 50 data points and they are in order. So that's going to make our job easier. They're in order going from left to right and then top down. So let's work on number 1. What is the percentile, or what percentile does the datum 66.3 yield? So look through that data set and find 66.3. The percentile is the number of data points that are, or the ratio of data points that are less than that number. So I need to count how many data points are less than 66.3. So there's 10 across the top, 10 in the second row, 10 in the third. So we're at 30, 31, 32, 33. There are 33 out of the 50 values that are less than 66.3. Right, so all I need to do now is turn this into a percentage by multiplying by 100. So 33 out of 50 gives me 0.66. And if I multiply that by 100, that's 66%. So 66% of my data is less than 66.3. Number 2 asks, what datum rests above 25% of the data? So I'm going to find the 25th percentile. So here we'll do the exact same equation, except now we don't know how many values we have to count, right? How many values out of the 50 gives me 25% of my data? So if I rearrange this equation and solve for y, I throw the 50 onto the other side, I find that y has to be 12.5. So I need to count 12 and a half values to get to my 25% mark. So 10 across the top, 18.4 is 11, 20.5 is 12. So 12 and a half falls right in between 20.5 and the next point, 22.4. Right there is 12 and a half, right? That's my 12th value. This is my 13th value. So that means this point right there has 12 and a half less than it, or it's greater than 25% of the data. So that means we'll take that 22.4. That data point has 25% of your data less than it. All right, so you can tell that 1 and 2 are really asking the same thing, or we use the same equation. They're just asking it in different directions. Number 1 wanted the data point, number 1 wanted a percentile of a data point. Number 2 wanted the data point that gave a certain percentile. Number 3, in the same vein as number 2, what datum gives the 90th percentile? So how many values do I have to count out of my 50 to get 90%? So I do the same thing. I solve for y. 0.9 times the 50 gives me y is equal to 45. So we go back to our table and we count 45 values. So 10 across the top, 20, 30, 40, 1, 2, 3, 4, 5. So the 45th value is 1, 2, 3, 4, 5, 85.4. Now I can't take that 85.4 because it doesn't have 90% less than. It is the 90% mark. So what I need to do is take the 85.4 and I need to average that with the next value, 86.3. Now, if I do that, what am I going to get? 85.4 plus 86.3 divided by 2 returns 85.85. So even though 85.85 is not in my data set, we'll say that that's the point that gives us the 90th percentile. Finally, number 4, create a modified box plot to represent the data. So the box plot is composed of the minimum, the maximum, and the 3 quartiles that are in the middle of our data, Q1, Q2, and Q3. So our minimum is immediately observable. That's our smallest data point, 2.6. Our maximum is also easily observable from the table, 161.3. Now to find Q1, well, that's the same thing as the 25th percentile, which we've already found. Right, that was number 2. So 22.4 is my Q1. Q2 is the median, or the 50th percentile. So Q2, we'll set up the same equation. How many values do we have to count out of the 50 to get 50% of your data. And if you do this, you have to count 25 values, which, because you're counting an integer amount, just like we did in number 3, we have to average the 25th and the 26th value. If you do that, you find that Q2 is equal to 52.45. And finally, Q3, that's the 75th percentile, or the third quartile. How many values out of the 50 will give us 75% of my data? So if we rearrange the equation and solve for y, 0.75 times 50 gives me 37.5. So I count over 37 values, and then I can grab that 38th value, which is 72.9. All right, so let's plot this. We've got 2.6 right there. Q1 is at 22.4. Q2 is pretty close to Q1 at, actually not too close, it's 52.45. Q3, the right-hand edge of the box, is 72.9. And then I extend all the way up until my maximum at 161.3. So this is the regular box plot. If I wanted to create a modified box plot, I need to start thinking about outliers. What is significantly far away from my data? So the way that we do that is I first compute the interquartile range, or Q3 minus Q1. It's effectively the width of that box. The interquartile range here is 50.5. I will then beef that up just a little bit. I'll multiply it by 1.5 to make it half larger. So 1.5 times my interquartile range is 75.75. So that's the distance that I want to move away from the edges of my box, away from Q3 and Q1. Now, if I do that, let's keep that on the page. If I take Q1 and I subtract 1.5 times my interquartile range, I get minus 53.35. Now, we don't have any negative values here, right? My smallest value is 2.6. So we don't have any significantly small values. Let's see if we have any significantly large values. If I take the right-hand side of my box, Q3, and I add this 75.75 number, I get 148.65. So there, we do actually have data that's outside of that range, that's further away than that number, 148.65. So in our construction of the modified box plot, we don't have any significantly small values. So our bar still extends to the smallest, not 2.8, 2.6. Did I say 2.0? No, it's 2.6, yeah. All right, Q1 still happens at 22.4. Right, effectively your box doesn't change. Your Q2 is still 52.45. And your Q3 still 72.9. But now, because we have significantly high values, your bar is only going to extend to that 148.65 number. And then any value that's outside of that is going to be considered significantly high. We only have the 1. Our maximum over here at 161.3 is significantly far away from our box, using this idea of 1.5 times the interquartile range. So this is the modified box plot.